So, as we know, this week we have started with a new lesson, which is multiplication of a vector by a real number. Our previous chapter was about addition of vectors. So now we are going to start by multiplication of a vector by a real number. So if you have a vector AB and you need to construct a vector CD such that CD equals KAB. Okay, if K is positive, then U and KU have the same sense. And if K is negative, then they will have opposite sense. If you look at CD, for example, CD is 2AB, then 2 is a positive number. So as you can see, AB and CD, they have the same sense. Now we constructed the vector EF such that, for example, EF equals minus 2AB. So as you can see, AB and EF have opposite sense because minus 2 is a negative constant. So starting from now on, if you multiply a vector by a constant, if this constant is positive, then you will get a new vector of the same sense. If K is negative, then you will get a new vector of opposite sense. Of course, we have particular cases. If you multiply a vector by 0, you're going to get 0 vector. And let us look at this example. Here we have a vector AB, and we are asked to construct the vector CD, such that CD equals 2 over 3AB. So in this case, as you can see, 2 over 3 is a positive constant, then AB and CD will have the same sense as you can see here. Okay, so CD and AB, they have the same sense. But how do we construct it 2 over 3? You just measure AB and you divide AB into 3 parts. CD will be 2 parts out of 3 AB. Here we will have some properties. If you have two vectors u plus v, if you multiply them by alpha, then you distribute alpha for both vectors. Also, if you have two constants, you can add them and then multiply them by u, or you can distribute alpha and beta each alone for you. So these are some important properties. What I'm trying to say that if you have 2ab plus 2bc, you can take 2 as a constant outside, 2 into ab plus bc. If you have 2ab plus 3ab, you can add 2 and 3 such that you will have 5ab. These are common properties that you have to know that they also apply on vectors. Now, what's the meaning of collinear vectors? Collinear vectors are two vectors that have the same direction, so we call them collinear vectors. And we admit that vector 0 is collinear with all vectors. Of course, this is a common sense. So how can I tell that two vectors are collinear? Two vectors are said to be collinear if you have here a constant k and a common point a. Look at AC equals KAB. So definitely A, B, C are going to be collinear points. I'm going to take an example. Here we have A, B, C, D as parallelogram. And we need to plot the point E such that AE equals 1 over 4AB. What I'm trying to say that I have to divide AB into 4 equal parts such that AE is 1 part out of 4. So that's why A, E, and B are collinear. So why they are collinear? Because they have a common point A, and here we have a constant K. Also, you can construct E in any other option. For example, A equals minus 1 over 4 CD. This is AE and this is CD. These two vectors, they are not collinear. They have the same direction, okay? Now, the particular points, the midpoint of a segment, you have to know that if I have midpoint of a segment, then IA plus IB equals to 0, or AI equals IB. And you have to know that MB plus MA equals 2MI, or MI equals half MA plus MB. So the most important things that you have to know is MA plus MB equals 2MI, or MI equals half, sorry, MA plus MB. Also, a particular point, we have the center of gravity. The center of gravity G of a triangle, you know that the center of gravity is the intersection of the 3 medians. So GA plus GB plus GC equals to 0 if G is centroid. Also, you have AG equals 2 over 3 AM, and GM is 1 over 3 AM. So these are the properties of the center of gravity or the centroid. Here we have a lot of solved exercises that you can practice them. Also, we solved important questions in the book. We solved exercise 2 that teaches you how to construct vectors according to a given K. We solved also exercise 7, 9, 10. So I ask you to practice them again, and the solution it's found in the notes in the copybook. And next week we will have a small quiz about this lesson, and we are going to continue the other exercises. We are going to solve, for example, 15 and 16. These are two important questions, okay? So this is our lesson. Those are the important notes that we have taken this week.